my dear students, welcome to Deeksha Karnataka, and today's class we are basically discussing the second part of the chapter electric charges and field. I hope that I am audible and visible. Yes, I can see. Hello Omkar, how are you? And those who anyone watching from your second year class waiting for Comet K results, just a new update has come just recently that Comet K results will be published at 6 p.m. Not at 4 p.m. So if you are someone who just came into our live about Comet K, thinking about Comet K results, so results is delayed by 2 hours. So that is the news. Now today we are basically discussing the second part. As you know, we have discussed in the first part. Let's go back to our chapter table. So in the first part we have discussed conductors and insulators. Basically we started with electric charge, properties of electric charge, charging by induction. Then we moved into conductors, insulators, basic properties of charges, and Coulomb's law. So up to Coulomb's law everything is done in our first class. Now we will start our class from electric field lines, and then electric dipole. So this will be our main point of discussion today. In the dipole we will discuss electric dipole moment, electric field due to a dipole in an external field. So these are the major point of discussion. What is the difference between ACE 2007 and Pariksha Veera paid version? So Omkar, ACE 2007, here we are basically discussing the lectures happening on YouTube. Okay, everything is free, whereas in Pariksha Veera you will get a proper schedule. Okay, everything will happen. So suppose in YouTube what happens sometimes, I am sick, or something happened, some important updates came, so YouTube series may be paused for a day or two, whereas in Pariksha Veera paid batch it will be continuously, the lecture schedule will be there, everything will happen according to the time. And one more important, very important part of the paid batch is that first of all you will get access to our app. Okay, through that app you can ask all of your doubts. The app itself will solve the doubts. If you still have any more doubts, you can come to our live doubt clearing session, where it will be dedicated for your doubt clearing. Okay, where teachers will discuss, take turns, all the teachers will take turns, and they will address your doubts. Maybe it's theory, maybe it's question, maybe you have some general doubts, so everything will be cleared in the doubt clearing session. That is one important thing. And the another part of Pariksha Veera is that you will get monthly tests, you will get weekly tests, sometimes you will get the complete whole syllabus tests, you will get part tests as well. So that is not part of our free YouTube batch. Okay, the teaching, the concepts obviously will be same. Okay, in our paid batch the teaching is not different at all. The scheduling is important, where you will get the lectures on time, you know when the lectures are going to come. Okay, and during the lecture generally there will be no outside discussion too much. Okay, if you have any doubts you can ask, that's it. Okay, no other conversation, only teaching will happen. Okay, so it is more focused. So if you are someone who is lacking, who is not able to concentrate through YouTube, or if you someone who has lot of doubts, or if you are someone who wants a methodical approach to complete your syllabus and you're ready for your exams, then it is very good for you. Okay, and we generally try in our YouTube batch or in our paid batch, we always try to align it along with your FA1 half yearly. Okay, then FA2, etc. We try to align the syllabus of the chapters so that you are prepared for that tests as well. So this is basic difference between paid batch and free YouTube batch. Okay, in paid batch generally we do more PYQs than in YouTube batch. Okay, YouTube batch the PYQs we cannot go beyond certain limits, so that's why paid batch we do more PYQs, more detailed PYQs. Okay, if there is a one PYQ, similar PYQ is coming, then we skip that in our YouTube, but in similar PYQs are also done in our paid batch. So that is the basic difference. So the offerings are more. Okay, teachings will remain same, as I mentioned. So if you are someone who are not willing to pay, that does not matter. If you are someone who is very focused in your own way, then you do not need to join the batch. That's it, right? Omkar, the classes will start from 15th of June onward. So once the lecture programming is done, we will definitely share it with all of you. Don't worry about it. Okay. But the classes will start June 15th. Before 1 week before, we will definitely share the schedule, etc. Okay. Now, so let's continue with today's class. So first we will discuss about electric field. Okay, so what is electric field? So in our last class we have seen that Coulomb's law is basically given by F is equal to KQ 1 Q2 by R square. Now let us see, let us say that we have two charges, capital Q and small q. Okay, so what is the force between them? Force between them is basically given by K into small q capital Q by R square. Obviously what is K? K is nothing but our Coulomb's constant. K is nothing but our Coulomb constant, which is 1 by 4 pi epsilon naught. Epsilon naught is free space permittivity. Okay, epsilon naught is our free space permittivity. From epsilon naught you can also you know the value of K, 9 into 10 to the power of 9. Epsilon naught is 8.854 into 10 to the power of minus 12. With practice these values will be integrated in your head, so that you will never forget these values. So that is very important thing. Now suppose after some time we remove this charge. If we remove this charge, will there be any effect of this capital Q be there? Will there be any effect of this capital Q be there? That is the main question that we have to ask ourselves. So when we talk about force, it has to be two charges, right? But instead of two charge, if we have only one single charge, then what is the effect of this single charge at the same distance? Is there any effect there or not? Okay, so to understand that, what we can do, if we have to put a single charge, unit positive charge, which is also sometimes called a test charge. Test charge means it is only for testing purpose. It does not have any other property than testing. Okay, so basically it's like a you say if you visit an ice cream shop, they give you some testing for testing. Okay, right, give me this, I want to test it. After ice cream parlors, generally modern ice cream parlors, they generally give you 1 spoon of tester, right? So this is like that. Okay, it is not that you are actually purchasing it or you are actually having it. It's like only for the purpose of testing. So this one unit positive charge is called a test charge. Now how to do that mathematically? Mathematically what we have to do, we have to take this small q and we have to divide it this side. Okay, so F by Q is actually KQ by R square. Now this F by Q can be considered as force per unit charge. This F by small q can be considered as force per unit charge, because if you take this small q charge to be equals to 1, then this becomes force, right? But we do not know exactly what is this force, so this is a very special case, so that's why it is called force per unit charge, and that is represented using the term called E. Here E is the electric field. Okay, this is called electric field. So electric field is coming from the situation where instead of having a fixed amount of charge, we removed it with a test charge, and we say that this is electric field. This is the effect of any one charge at a point. It is the effect of one charge at a point. Now what will happen if more than one charges are present? That also we will discuss, don't worry. So if you are thinking, sir, there is on the multiple charges can also be present. Yes, multiple charges can also be present. So don't worry, multiple charges cases will also be discussed. So effect of one charge at a point is basically electric field due to that point. Now, so this capital Q is called source charge and small q is here can be considered as test charge. Okay. Now, electric field due to a charge capital Q at a point in space may be defined as the force that unit positive charge would experience if placed at that point. So if you place a unit positive test charge at this point, whatever force is experienced by this unit positive charge, that is called electric field. Now electric field is a vector quantity. Electric field is a vector quantity. For a positive charge, electric field is pointed outward. For a negative charge, electric field is pointed inward. We will discuss that again, don't worry. So for a positive charge, electric field is pointed outward. For a negative charge, electric field is pointed inward. Okay. So electric field is a vector quantity, very important part to remember. It's not a scalar, even though we are writing it like a scalar, but it is a vector quantity. It has a direction. Now alternatively, if a charge small q is kept inside an electric field E, then the force experienced by it is given by Q into E. This is a actually so from force we defined electric field. From electric field we are coming back to force, because in some cases we do not know exactly what causes the electric field. It can be anything. Okay, we do not know what is the reason that producing this electric field, how much charge is there, where is the charge located, but we can use our device and we can actually measure the electric field. Okay, so if you know the electric field, okay, it is very important for us. Does this force remain same in water and air? No, red rhino. So I will, because you have asked it, I will explain it, don't worry. The force actually does not remain same. Force, electrostatic force is dependent on the medium between the charges. Okay, so I explained that in my last lecture as well. I will explain it once more, don't worry. So if you put a charge here, this will also experience a force. So what will be the direction of that force? That we will see. But this charge also experiences a force. So some cases we do not know origin of the electric field, we only know the electric field exists there. So if you put a charge, it will experience a force. That's why F is equal to Q into E. Now we know that electric field scalar form is given by K capital Q, we are using capital Q by R square, right? This is the general form. So if you put K, instead of K, if you put 1 by 4 pi epsilon naught, okay, by R square, so definitely this epsilon naught is for free space. Free space means vacuum or air. Okay, air and free space almost have same epsilon naught, so that's why it is free space or air. But if you put it inside a medium having a different dielectric constant, for example water or say glycerin or say glass, you can embed a charge inside a glass and you can create an electric field there also. So if you change the dielectric medium, the electric field will basically 1 by dielectric constant. Here K is dielectric constant, do not confuse with small k and capital K. I always tell the students that this is Coulomb constant small k, this is capital K dielectric constant, into 1 by 4 pi epsilon naught Q by R square. So basically it will be E by K. So electric field will reduce electric field will reduce when you put this inside a dielectric medium. That is one of the reason we will see in our next chapter, in capacitor chapter, that why we use a dielectric medium between the capacitor plates. This is the one of the reason. Okay, so lower the electric field, that means you can increase the capacitance. That we will see in our next chapter. But you have to remember that if you put a dielectric medium inside a dielectric medium, if you are trying to measure the electric field always reduces. Okay, electric field do not remain same if you try to measure the electric field inside water or inside air. So because electric field reduces, force also reduces. So force also decreases. If you want to measure this force, suppose you have an electric field, you are measuring the force on a charge in air, and same electric field is present inside the water. If you are trying to measure the force on the charge on water, the value will be different, okay, because of the dielectric constant. Okay, so that is the question to your answer, right? Hello Rajpal, how are you? Right, now let's move on to the next part. Before moving on, we have to solve one example question. A charged particle of mass m and charge q is released from the rest in a uniform electric field E. Neglecting the effect of gravity, the kinetic energy of the charged particle after t seconds. So it is given, charge is given, electric field is given, suddenly they are asking kinetic theories, kinetic energy. So it is like a completely different kind of question, right? Actually not, it's actually easy question. Okay, we know that kinetic energy is given by half m v square. Okay, so mass is given, so if you can somehow calculate this velocity v, you will be able to calculate the kinetic energy. So this problem is basically how to calculate v. So think about it, try to solve it. In the meantime, let me have a cup of tea. I will give you 2 minutes. Solve it. Hello Suvarna. Try to solve this question on your own so that you get a clarity on how to solve questions. Okay, so enough time is given. None of you have able to solve it. Let me solve it. So here basically what we will be doing, we will try to find velocity. How to find velocity? We have to use our very important formula, that is father equals to ma. Father equals to ma. F equals to ma. Okay, so acceleration we can calculate, from there we can calculate velocity. Now how to calculate acceleration? So if you see here, the charge is given and the electric field is given. So if charge and electric field both are given, we can write force is equals to Q into E. So if we can write force equals to Q into E, we can also write this is equals to MA. So from here A equals to QE upon M. So acceleration is calculated. Now because we know that V equals to U plus AT, equation of motion, V equals to U plus AT. Now here it is starting from the rest, so U is 0. So velocity V will be A into T only, because U is 0. So now you put the value of acceleration A that you have calculated. So basically this is the application of whatever we have learned, that force is basically Q into E, and once you know Q into E, basically from there we can apply our Newton's second law of motion and we can calculate the acceleration. So V equals to Q into E upon M into T. So this is the velocity. So time, that's why the time is given in this question. Okay, that's why the time is given to calculate V. Now we will come back to our original formula, V is equal to half mv square, and we will put the velocity value, that is QET by m whole square. Now if you see, the value is very simple. It will come out to be m into q square e square t square by 2m square. So one of the m will cancel and you get the answer q square e square t square by 2m. So the correct answer is q square e square t square by 2m. So option C is correct answer. Yes, Suvarna, correct. Right? So correct answer. Option C is correct. Now, let's move on with our discussion to the next part. The electric field due to a system of charge exists at every point in three-dimensional space. Okay, theoretically, electric field exists from very near to the charge till infinity, each and every possible direction. So if you consider a system of charge or single charge, does not matter, system can be only of consisting one charge as well. Theoretically, electric field can exist in all possible direction in three-dimensional space. Three-dimensional means up, down, right, left, okay, forward, backward, and combination of these x, y, z system, right? So it exists in all possible direction in three-dimensional space, and theoretically electric field exists from very close to the charge till infinity. Okay, till infinity. At infinity electric field is 0. Obviously infinity means very far away. Okay, for a positive charge the electric field will be directed radially outward from the charge. So as I mentioned, for a positive charge electric field is radiated radially outward. Okay, it is radially outward. Whereas for negative charge the electric field vector at each point points radially inward. So if you are considering negative charge, it is radially inward. Now remember, you might feel this is easy, but this is a favorite PU question. In the PU they will ask you draw electric field for a positive charge, for a negative charge, or for a dipole. So these are the very common question. Or sometimes in MCQs they will give you a special combination of charges, and they will say which one of them actually represents the correct diagram. So that is also possible, right? Pixtoon Comet K result was delayed till I think 6. I don't know whether they have released it yet, because before coming to the class we are trying to find about Comet K results, and we realized that result was delayed. Initially it was the website was not loading, and then they gave a message that result is delayed up to 6 PM. Okay, Pixtoon, but if it is released you can go check that out. Okay, because they are having some internal trouble, internal server errors, that's why they delayed it by 2 hours officially. But if they have released it, then you can check your result and let me know what is your no sir, out. Okay, I got 7K rank, 93 percentile. Pixtoon, wow, good. 7K rank is good in Comet K, not bad. In terms of Comet K standard, 7K rank is good, and 93 percentile is obviously good, right? Now you should make a list of colleges. I have done one video yesterday, top 20 colleges. Okay, we will see that you can easily get into one of the top 10 colleges through the 7K rank, even if you are choosing CS. Okay, if you are choosing something other than CS, then also you can get into good colleges. Okay, yeah, welcome. Now let's see. Electric field due to a system of charges. System of charges means we have say positive charge, which have a charge say Q1, we have a charge say Q2, we have a charge say Q3 here, and so far and so on. So lot of charges are there in a space, and we are trying to find electric field at a point. Okay, each of them have different distances. So this one have distance say r1, this one will have a distance r2, okay, this one will have a distance r3. Some of them can be positive, some of them can be negative. And so how to find the net electric field at a point? To find the net electric field, obviously like Coulomb forces, you have to take you have to add them vectorially, vector addition. So it's a vector addition problem. We will solve some vector addition problem in future, but right now you have to remember it's basically vector addition. So when multiple charges are present, it can be given to you like that key. We have a square, one charge is located here, another charge is located there, another charge is located there. Okay, what is the electric field at the fourth corner? So basically remember, it is not, you cannot add them scalar, you have to use vector addition theorem. Okay, so you have to find the electric field due to charge q1, you have to find electric field due to charge q3, you have to find the electric field due to charge q2. Okay, and then you can basically find the resultant. Okay, and they generally, it comes in PU exams, and they will give you the value such that generally this is in the direction of this two. Okay, so if you add these two, generally these two vectors will give you a vector which is also in this direction. So finally last two you can add. So basically you find the electric field E1, you find the electric field E3. Okay, E1 and 3 is basically in the same direction. So basically for that you have to add E2 with this. This is the general structure for these kind of questions. Okay, we will solve this kind of questions in our future lecture, not today. Today we are only discussing theories, so that's why we are not discussing. Now let's look into the formula. So formula is very simple. E vector equals to sum of all the electric fields, and here if you notice the electric field is given in vector form, and when you are adding them it is also given in vector form. This is representing vector addition, not scalar addition. So very important that we are only doing vector addition, not scalar addition. Okay, now let's move on. Properties of electric field lines. Field lines start from positive charges and end at the negative charges. If there is a single charge, they may start or end at infinity. Okay, if it is a single charge, they may just a second, give me a second. Okay, now properties of electric field, and this is very important. Okay, this is very important. Every year in all the exams that you are going to give, FA1, midterm, pre-board and board, you will find this question. Okay, sometimes it may be asked mention 2 properties, sometimes it may be asked mention 3 properties, and for college internal exams sometimes teachers give write 5 properties. So everything is possible. In board exams 5 properties never came. 2 properties or 3 properties are the most common question, either 2 marker or 3 marker question. This is one of the most important concept, and based on these concepts also we see some MCQ questions as well. Field lines start from positive charges and end at negative charges. If there is a single charge, they may start or end at infinity. Okay, so if this is a positive charge, this is a negative charge, so electric field start at positive, end at negative, start at positive, end at negative. This is also electric field due to a dipole. Okay, you can say electric field goes like this. Okay, we will see dipole again, don't worry. So electric field basically starts at positive, ends at negative. If it is a single solo charge, okay, solo charge, it can go up to infinity as well. Okay, So this is the first property. In charge-free region, electric field lines can be taken into continuous curves without any breaks. Now, one more point, important point that I forgot. Why we need to draw electric field lines? What is electric field lines? So, electric field lines is the representation of electric field itself. Okay, electric field lines are representation of electric field itself. Electric field sometimes can be abstract, okay, unlike forces where you can see what is the direction between two charges, etc. Electric field is an abstract concept. It does not have a proper way to represent it. So that to represent electric field, we use a diagram. That diagram is called electric field lines. If you draw a tangent and at any point, that tangent gives you the direction of electric field at that point. I think that is also a property of electric field lines. Okay, so electric field is the pictorial representation or vector representation of electric field. Okay, in a charge-free region, electric field lines can be taken to be continuous curves without any break. So that means electric field lines is not represented like this. This is not electric field lines. Electric field lines are continuous curves. So if you are drawing electric field lines, it has to be a continuous line. It can be line, it can be curve, it can be whatever it is. Okay, electric field lines is not broken anywhere. It is a continuous line. Okay, if there are no other charges present. Okay, that is very important point to remember. Two field lines can never cross each other. If they did, the field at the point of intersection will not have a unique direction, which is absurd. Okay, so two field lines can never cross. So as I mentioned, if suppose there is an electric field line in this direction, say E1, there is another electric field lines in another direction, say E2. Okay, so this is not possible. Why this is not possible? Because if you draw a tangent at this point, the electric field will point in this direction. If you draw a tangent in this direction, it will be pointing in another direction. Now electric field being a vector quantity, it will have a unique one direction only. Okay, it will have a unique one direction only, not bidirectional or tridirectional. Bidirectional means two different directions. It is not possible. A vector quantity will have only one direction. Okay, that's why this does not make any sense. In fact, if two electric field lines do come close to each other, they will give rise to a new electric field which is completely different from their source electric field lines. Okay, so they will basically add vectorially and they will give you a completely new electric field which is different from their source electric field. So you might think I have a positive charge, I have a positive charge, I will bring them together, the field lines will intersect. That does not happen because they will realign their electric field lines so that they have no, they do not have to cross each other. Okay, so electric field lines are very good friends. They do not cross each other. Electrostatic field lines do not form any closed loop. Very, very important point. Okay, electrostatic field lines do not form any closed loop. This is one point which is indifferent than magnetic field lines that we will study in future. Sir, I saw your physics MCQs before comment ke exam and that helped me a lot. Thank you, sir. Will never forget you. Thank you, Pixtoon. So we were trying to make some comment K videos, but we could not do it. So that's why we gave you the access to our paid batch course, paid batch that was actually recorded for paid batch, and we same day the paid batch student got the lecture, you also got the lecture. We are little bit sorry because we could not do a long regular series for comment K because we were a little bit cramped at that point of time. There are a lot of things going on in the back end, so that's why we could not take a regular YouTube series. But yes, we appreciate that you have watched it and that helped you. I really feel thankful because you have trusted me and our channel for that. Obviously this is your hard work. Yes, we can help you out, but it is mainly your hard work that through that you get this rank. It is not because of my video, but it is because of your hard work. Do not forget that. Electric field is in free space decreases as we move in the direction of the electric field lines and vice versa. Okay, so electric field line in free space decreases as, so if you see an electric field, suppose like this, okay, so as you move in the direction of electric field, okay, here electric field is high, value of electric field is high. If you move in the direction, electric field value decreases, so here electric field is low. Okay, we will solve some KCET MCQs in future. There you will see this concept, even this concept is also came in KCET exam. Also, one more important part is that electric field line, as the distance between electric field line increases, the electric field also decreases. Okay, so if equally if you distribute the electric field lines, okay, if they are parallel to each other, that means electric field is constant. If they are not parallel, if the distance changes, okay, electric field basically decreases with the increasing distance between the field lines. So it is a directly proportional between the distance between the or inversely proportional with the distance between the field lines, two consecutive field lines. So as the distance between two field lines increases, the electric field value also decreases. Okay, closer the field, stronger the field, further they are, weaker the field. Okay, so if you are stay close to someone, basically that means the bonding is strong. If you stay further from someone, the bonding is not that strong. Same thing for electric field as well, right? Now next, so electric field is done. Now we will move into electric dipole and we will discuss electric field due to electric dipole. Okay, normal electric field is done now. Now let's move into electric dipole. Two equal and opposite charges separated by a small distance is known as electric dipole. So two equal and opposite charges separated by a small distance is called electric dipole. Common example, HCl. Okay, any molecule if you take, okay, there are many molecules which behave like electric dipole. Okay, sometimes they behave like electric dipole in the presence of external field, sometimes they are already polarized, so they are called polarized and non-polarized. We will discuss polarized, non-polarized in our next chapter, that's why we are not discussing that in today's lecture. Next chapter we have a section of polarized and non-polarized molecules, but you should remember that dipole basically, if you consider a molecule like HCl, there the distance between them is very, very small, okay, in the order of a micrometer or millimeter, micrometer or nanometer, okay. So the bond length is very small, okay, and we know that the chlorine has high electron affinity, so it will attract the electron pair that is participating in this bonding. So chlorine will automatically take the electrons towards it, and that's why the hydrogen becomes delta plus and chlorine becomes delta minus. Another example, most common everyday thing that we use in our day-to-day life, which is nothing but our own H2O. Okay, right, H2O. So this is oxygen. This is oxygen, this is hydrogen. So we know that oxygen is very highly electron affinity of oxygen is very high, so it will take the hydrogen's electrons as well. So it will give the electron, then it will take it back. So all the electrons are staying closer to oxygen, so it will be negative twice of delta. This will be plus delta, this will be plus delta. Okay, and you can find the resultant dipole moment of this combination as well. Okay, resultant dipole moment of this combination can also be calculated. So this is basically it. So dipole is basically when two equal and opposite charges are separated by a small distance, that is called dipole. Sometimes a dipole moment of a system of charges is also possible if you can divide them into pairs of two equal and opposite charges. For example, in this case you can divide it by minus delta, minus delta. So this is a dipole, this is another dipole. So if you can divide a system into two equal and opposite charges and the distance between them is small, then that also can be considered as dipole. Okay, dipole moment. Now remember, if you have studied dipole moment in chemistry, physics dipole moment direction is completely different, so be careful, pay little more attention here. Okay, now let's see. Dipole moment. Electric dipole moment is the product of magnitude of one of the charges and the distance between them. So dipole moment is defined as if you take one of the charge, any one of the charge, magnitude, plus minus does not matter obviously. If you take negative charge also, its magnitude is positive. If you multiply it with the distance between the charges, then that gives you the dipole moment. Okay, so take any one of the charges and multiply it with the distance between the charges, that will give you the dipole moment. Okay, dipole moment is a vector quantity. Dipole moment is a vector quantity. Okay, here if you see, the dipole moment is represented as P vector equals to, P is the symbol for dipole moment. It is given by Q into 2a n cap. Q into 2a n cap. N cap is the unit vector from negative to positive charge. N cap is a unit vector from negative to positive charge. Thus, the direction of dipole moment is from negative to positive charge. Very, very, very important. So, dipole moment is a vector quantity which points from negative to positive charge. Dipole moment is a vector quantity which points from negative charge to positive charge. Okay, it's a vector quantity and the direction is from negative till to positive. Okay. Now, next, electric field due to a dipole. So there are two cases, one is on the axial position, one is on the equatorial position. So how to calculate it, I will not do the detailed calculation. You have to practice that for your PU board exam as well, or if you are studying from CBSE also, the derivation is important. So first you have to take a positive charge. Okay, a positive charge, say this is positive, this slight red one is negative. Okay, so this is positive, this is negative. Okay, the charge of this is say Q, this one is minus Q. Okay, the center of the dipole, always measure the distance from the center of the dipole. Always measure the distance from the center of the dipole. So the center of the dipole, the distance is smaller. So from the positive charge, the distance is from the positive charge, the distance, just a second. From the positive charge, the distance is so if you see here, right, so this total distance here is smaller. Okay, this total distance is smaller, so this much distance must be r minus a. Similarly, if you measure the distance from the negative charge, okay, if you measure the distance from the negative charge, then the distance will be r plus a. Okay, so this will be r minus a, this will be r plus a. Now, electric field due to positive charge is away from. Electric field due to a positive charge is always pointing outward, that means away from. Electric field due to a positive charge at any point always point away from the charge. Okay, and electric field due to a negative charge always points towards the charge. Electric field due to negative charge always point towards the charge. Electric field due to a positive charge always point away from the charge at any point. Okay, remember this is also very, very important point. So if you have a positive charge here, if you are trying to find electric field, so positive charge means electric field will be away from. If the charge is negative, electric field will be towards. Okay, so electric field due to positive charge is away, electric field due to negative charge is towards. So one, if you take this is positive, this will be negative because of the opposite direction. Remember, whenever you are finding electric field, this is also one important point to remember while calculating electric field. Electric field due to anything. Okay, when you calculate electric field, okay, never ever consider the sign of the charge. Sign of the charge is not important when you use the formula E is equal to KQ by R square. Okay, sign is not important. Sign of the charge is not important. What is important? Direction is important. Direction. So sign of the charge is not important, direction is important. Right? Why direction? Because obviously electric field, if they are in the same direction, electric field always added. If they are in the opposite direction, electric field will be subtracted. If they are in the any other direction, vector formula you have to apply. So remember that, do not use positive, negative and confuse yourself while calculating electric field. So many students at the beginners level, they use the sign of the charge as well while calculating electric field. Do not do that. Okay, so electric field while calculating, do not use any sign of the charge, plus minus, that is confusing. Okay, only thing that you have to consider is the sign of the direction. So if when calculate two electric field due to two different charges, if they are in the same direction, you can add them. If they are in the opposite direction, you have to subtract them. If they are in any other direction, you have to use vector geometry to add them. Okay, so here they are in the opposite direction, and as you can see, because the positive charge is closer to the point, the net electric field positive will be more, okay, and negative will be less. So basically net electric field can be calculated as E plus minus E minus. That's it. You use it, calculate it, and your answer is done. Now, so basically you have to use the formula to calculate the electric field, same formula, this formula, and basically add them. And one more approximation that you have to do is that the distance is very, very greater than the distance between the dipoles. Okay, so distance of the point from the dipole is greater than half length of the dipole. That is one approximation that you have to use. It is a very common appropriate approximation. So using this you can calculate, and this is called axial position of the electric field due to a dipole. Now if you see that the net electric field points in this direction, this is the direction of axial electric field. Okay, what is the direction of dipole moment? Dipole moment points from negative to positive charge. Dipole moment points from negative to positive charge. So this was our negative charge, this was our positive charge. So dipole moment is also in the same direction. So dipole moment and electric field, they are in the same direction. So that's why this is the electric field formula. So if you see the electric field formula, electric field and dipole moment, they are in the same direction. Sir, this batch will stop in the middle house. The Sankal batch was stopped. Omkar, we cannot say anything about that. We were not getting enough views and responses from our Sankal batch. That's why it was stopped. Okay. If you liked our recordings, if you liked our lectures, and if you share it with your friends, okay. We felt that Sankal batch started a little earlier. Okay. The response was not happening as the efforts that we are putting, we are not getting back enough efforts. So if the views continues, if the response, if you continue to respond in our lectures, definitely it will be continued. Okay, that is basically it is not in our hands, it is in your hands. You if you want to share this, if you want this lecture to be continued, share it with your friends so that they also watch. Okay, watch time increases, views increases, subscription increases, then our series will not be stopped. So basically it is in your hands. You share this with your friends. We will try to make this more interesting. More views are there, we will try to make it more engaging, more interesting as much as possible, right? Whereas in the paid batch, if you come and join, there is no point of stopping it, right? But in YouTube, basically we have to take the feedback of you only, and if we get enough views, because we thought that okay, let's start the batch, start the free batch little earlier than usually what we do. Okay, and we were not getting enough responses last year batch, but we got the response later on when the Sankal batch was stopped. Many students came, they were our regular students. They do join us back in the later series that we have done, but we were not reaching enough students that we are expecting to reach, right? So that's why Sankalp batch was stopped. Initially the response was good. We continued for 1.5 months, and then we were seeing that slowly the response was going down. After first FA onwards, the response was going down. So that's why we stopped the Sankalp batch. But if we get the enough responses, definitely we will not stop it. We will continue it. Okay, so don't worry about it. So basically, as I mentioned, you have to share this lecture with your friends, your classmates, so that they also join our channel, and then ask them to share it with their friends as well, so that we get enough views, and we are not allowed to stop. So you have to make sure that we cannot stop this series, right? Now let's move on. So this is the dipole on the equatorial plane. Equatorial plane means so if you see a triangle, okay, if you see a triangle, so if you draw a line which divides the triangle into two equal parts, that is called equatorial line. Okay, now if you do not have a triangle, if you have a line, single line, okay, if you consider a line which basically bisect into two parts, it is called equatorial line, or it is also called perpendicular bisector as well. Perpendicular bisector or equatorial line, same as our Earth's equator. Okay, equator is basically dividing our Earth into two equal halves, north half and southern half, right? So it is like the same equator, which is basically dividing this into two parts. Now in 3 dimension, instead of calling it a line, it's basically a plane. It's a plane. Okay, it's a plane, which is a 3-dimensional thing. So if you try to draw it, it will be a little complicated. Let me see if I can draw it. So that's why it is called equatorial plane. So this is a straight line. Suppose this is a straight line, and you are trying to find the equatorial plane for this. Okay. So it is basically like this. It's a 3-dimensional plane, okay, which is basically dividing this into two equal parts. Now we cannot draw this in our day-to-day life, so that's why whenever we say equatorial plane, we actually draw the equator itself. This is the equatorial line. This is the equatorial line, and we only draw the equatorial line and not the entire plane, which is not possible for us to draw. Okay, so just for your common reference. Now when you try to find the electric field on the equatorial plane, the situation is slightly tricky than axial plane. What happens here, suppose this is our positive charge, this is our negative charge. What happens here, obviously, let me go back to our arrow. Now if you see here, so this positive charge, if you are trying to find the electric field at this point, you are trying to find electric field at this point. So positive charge will have an electric field in this direction. Positive charge will have an electric field in this direction. The negative charge will have an electric field towards it. So negative field will have a electric field in this direction. Excuse me. Now together you have to use a vector addition formula. You have to use a vector addition formula to find the resultant of this. So how to do, you can use the, just a second, you can use parallelogram method to add these two vectors. You can use parallelogram method to add these two vectors. So parallelogram method means you take a parallel here, you take a parallel along this direction, you take a parallel in this direction, okay, and you will get a resultant which basically points in this direction. Okay, you will get a resultant which points in this direction. Okay, so basically for equatorial plane, this is specifically for equatorial plane, it does not valid for any other position. Any other position is anyway is not part of the syllabus. So when you calculate this electric field, you will notice that this electric field is, if you consider this angle theta, this angle will also be theta. So if this is positive, this is negative, then the net electric field will be E plus cos theta plus E minus cos theta. And one more important part about equatorial plane, because it's equatorial plane, this side is equal to this side. These sides are equal, so this forms an isosceles triangle. So this angle will also be theta, this angle will also be theta. This distance is r, this will be square root of r square plus a square. Okay, so this will be r square plus a square, and using this you can actually calculate the cos theta value. E plus E minus will be equal, and you can simplify and you will see the equatorial plane electric field is given by 1 by 4 pi epsilon naught P by r cube. Now if you consider the direction, electric field is in this direction, whereas the dipole moment is from negative to positive. So electric field and dipole moment, they are in the opposite direction. That's why there is a negative sign over here. So negative sign comes from the fact that equatorial plane and dipole moment are in the opposite direction. Also one more point to remember, if you see here, the axial plane electric field was 1 by 4 pi epsilon naught 2 p by r cube, whereas it is, if you take the modulus only, equatorial plane is 1 by 4 pi epsilon naught p by r cube. So from here also we can say that electric field axial modulus is twice as strong as the equatorial plane. So axial electric field is twice as strong as on the equatorial plane. And vector notation wise, axial will be minus 2 equatorial plane. So both have been asked in KCET as well as in your PU board exam. Hello Adil boy, yes, if you can watch, if you are repeating your KCET, definitely you can watch. No matter if you are 12th pass or you are studying in class 12th, it does not matter. The angle between, that's why we are not discussing PU related stuffs in our lecture. It is mainly we are focusing on the theories, PU stuffs, and this is focused more towards KCET. PU related specific stuffs we will discuss in our future lectures, not here. Okay, for example, derivations, okay, how to write the answer for certain questions, those we will be discussing in our separate PU series. Okay, here we are basically discussing mainly KCET theory and how to solve questions. In between also I am giving you what are the important for PUC exam as well. The angle between the dipole moment field, electric field is in this direction, dipole moment is in this direction. So this is negative, this is positive. So the angle between these two vectors is always 180 degrees. On the equatorial plane, angle is 180 degrees. On the axial plane, axial line, the angle between electric field and dipole moment is 0. So if it is equatorial plane, angle is 180 degrees. If it is axial line, angle is 0 degrees. 0 and 180 you have to remember, right? Now let's move on with the next part. Dipole in an uniform external field. So far what we are discussing electric field due to the dipole itself. Electric field due to the dipole itself, axial plane, equatorial plane, common angle also is possible, but as I mentioned, it is not part of the syllabus, so I am not discussing it. But if you keep a dipole in an external electric field, then what will happen? Okay, this will experience something which is called torque. What is torque? Torque is when two equal and opposite forces acts on an object but do not act on the same point. Very important part. Okay, if two equal and opposite forces acting on an object but they do not act on the same point, then the body starts to rotate. That is called torque. Torque is a rotational force. Okay, it's a rotational equivalent of force. So here if you see, this is our say negative charge, this is say our positive charge. Okay, now what will happen if you keep this combination of dipole in a external electric field E? So if you keep this dipole in an external electric field, the positive charge will experience a force in the direction of the electric field, okay, and the negative charge will experience a force in the opposite direction of the electric field. That is the properties, right? So these forces are equal and opposite. These forces are equal and opposite. So net force acting on the dipole is 0. Net force acting on the dipole is 0. So what about the net effect? Is it 0? No, net effect is not 0. So for that you have to calculate the torque, which is basically calculating this distance. If you calculate this distance and multiply with one of these forces, you will get the torque, which is given by, in vector notation, P cross E. Okay, torque acting on a dipole in an external electric field is given by P vector cross E vector. Scalar form wise, torque is equal to PE sin theta. Now remember, while doing this derivation, you will first arrive at this formula. From this formula you will say this is a torque is a vector quantity and it is represented as P cross E. Okay, now from this formula it is not clear whether it is P cross E or E cross P, but after a lot of experimentation it was found torque is actually P cross E. Okay, torque is P cross E. The order in cross product is very, very important. P cross E, and cross product means it's sin theta, dot product means it's cos theta. So these all things you have learned in your PU1 exam, right? Now let's move on. Now this torque will tend to align the dipole with the field E. When P is aligned with the electric field, the torque is 0. So this dipole will try to align the this torque will try to align the dipole in the direction of the electric field. So that means the positive in this direction, the negative in this direction. And once this is achieved, the torque will be 0 because sin theta will be 0. Okay, sin theta 0 means torque is 0. Okay, when the electric field is not uniform, very, very important point. Okay, if the electric field is not uniform, there will be a net force as well as a net torque acting on the dipole. So if the field is uniform, uniform means field lines are parallel, electric field value is constant, then only torque is acting, force is 0. But if the electric field is not uniform, then there will be a torque as well as there will be a net force as well. So the dipole will not only rotate, it will also move. Okay, so basically it will move in a rotating form. Okay, now let's move on with the our daily practice question. I will give you 2 daily practice questions today. Yes, this is the end of our lecture for the day. Okay, I will give you 2 daily practice questions. One is, an electric dipole with dipole moment 4 into 10 to the power of minus 9 coulomb meter is aligned at 30 degrees with the directions of a uniform electric field of magnitude 5 into 10 to the power of 4 Newton per coulomb. The magnitude of the torque acting on the dipole is. So what is the torque acting on the dipole? So very simple, torque is equal to PE sin theta. You have to use this formula and calculate the torque. Okay, next one is 27 identical drops of liquid carrying equal charge collides to form a large drop. The electric field on the surface of the large drop is dash times on the surface of the drop. Okay, so here we have 27 small drops. Okay, like that. They form one single drop. So if the electric field on this surface is ES, what is the electric field on this surface? Now you might require a formula for that. That formula we will discuss in our next chapter, next class. But you can still solve it by using simple logic as well. So try to solve it. If you are not able to solve it, let me know in the comment section below as well. One of you have commented me in my previous lecture video. I did check that out and I did mention that whether the answer is correct or wrong. Okay, Suvarna is already answering. Suvarna, once the live is over, you mention that in the chat section below. Okay, so I will be able to comment it back. Okay, right now I will not be able to comment it back, right, Suvarna? So if you are once the live is over, it will take some time for the live to close. Okay, it is being closed by our admin team. They close the live. Once live is closed, you mention that in the chat section, below chat section, right? Main chat, not in the live chat. Okay, I will not be solving this question. If you have any doubts, you can leave a comment in the chat. I will definitely try to address them. If not possible, then I will discuss that in our next class. Okay, and obviously two very important point for everyone. First of all, subscribe. Second of all, like this video, and if you want to download the PDF of this lecture, don't forget to join our WhatsApp channel. We are doing a lot of things in our WhatsApp channel as well, so do join there. And sometimes Jasmine ma'am do the things to chat with you guys also, so you can join our WhatsApp channel. There you will get the link of the PDFs of all the lectures we are doing. Okay, once the chapter is over, we will share one whole chapter link as with you, so don't worry if you are not getting the regular lecture notes. So we will share the notes. You will be able to download it. You will be able to use it for yourself for free as well. Okay, so do join the WhatsApp channel. Do remember to like this video and subscribe our channel. Share this video with all of your friends so that they can also join us in our next live class, right? Thank you everyone. Thank you. I will be back with another live hopefully Monday. Okay, till then, bye. See you.